Hello, Professor Natu. Let me introduce our project one. And here's the schematic of the circuit. This part is for PK 690, and this is part for the PK2. This one is color sensors or photo sensors. This one is the motor sensors. The PK2 we can show on this graph. We just need to use the first 5 pins of that, and pin 1 is VPP, pin 2 is VDD, and the pin 3 is the ground. Pin 4 is pass the data into the PK into the chips, and pin 5 is for clock to use. And for the project 1, our vehicle will follow the line, and the assignment for the project 1 is first self-navigation and follow a line, and the attention assignment is if you bunch it out of the line, it will find the line, go back and continue the self-navigation. And here's the PK 690, and the pin 1 connect to the PK2 and this part, pin 2, and this one connect to the pin 4. It's hard to show on this graph, and I will go back to this schematic. This is ground, this is data, this is a clock, and this part is a color sensor. This is a diode, and we need to resist to protect it. And this is a triangle, and weighs on the tip, and you can see here is a signal to go back to the PK, to go back to the chip, and if it's on the tip, and it will collect the sensor, and this part will looks like a shortcut, and it will go to the ground. So when it's on the tip, and the signal will send back 0, and on the contrary, if it's on the black table, and this one is cut off, and it will show the 5 volts. So that means the signal 1 for TTL signal. And in the program, we collect the information from the sensor and deal with them and give an output to the motor driver. Yeah, and the motor driver, there's some pins should connect to the ground. It's heat sink, and this before to run it, there's enable for this enable control the 1 and 2 is the left side, and this enable control the right side, and the pin 2 and the last pin 2 is the input from the chip, the PK 690, and the pin 4, and this 2 part is controlled by the red sensor. And how the motor drive is compared this one and this one. That is the output of this one and this one. If this one minus this one is positive, it will go forward. On the contrary, it will go reverse. If this pin and this pin are equal together, the motor won't drive anymore. And the same reason for this part. Here's the principle of the project 1. Thank you.
So this is the code for the follow and find line portion of the project. This is the extension for project 1. And if you look here, if you're on the tape, if the left sensor was on the tape last, then there's a variable called direction, and it'll make direction equal to 1. If the right sensor was on the tape last, it'll make direction 2. And down here, if it ever runs into the condition where it's all off tape, all the sensors are off tape, then if the direction is equal to 1, it'll go back to the right, and it'll keep doing that until any of the sensors find the tape again. Once it finds the tape again, it'll continue doing the follow line like it was before. If it's the other direction, then you're going to turn left if the direction is equal to 2. So if your right sensor was on the tape last, then you're going to turn left in the same condition to break the loop here as well. This is for project 2. So in this part, what we were trying to do is count the number of lines that we told the robot to cross. So what we have here, and we did the portion of the project where you also not only count the lines, but you're adjusting the robot so that it crosses the line perpendicular, so it's perfectly straight going across the line. So right here, what we have is, as you're approaching the line, if the left sensor comes on, it's going to make a little bit of a left turn. If the right sensor comes on, it's going to be a little bit of a right turn. And this is just like, as you're approaching the line, it's going to make a little tiny adjustment. And this is the loop where we were going to do the adjustment. As soon as all 3 of the sensors pick up the line, then it'll go into this loop where it's going to run 3 times, and it's going to find the line, it's going to reverse for a delay of 100 microseconds, and then it's going to go forward while the middle sensor is off tape. It's going to go forward, and it's going to, whatever sensor it picks up first, it's going to adjust towards that way. So if the left side hits first, it's going to go a little bit to the left. And it'll do this 3 times, and at the end of 3 times, it'll be pretty much straight on the line. After that, after it runs 3 times, it's going to count, and the count is incremented right here. And it's going to keep doing all of these until the number of counts that you specified here. So in our case, we're going to count 2 lines. So it's going to approach the first line and go back 3 times and adjust, and then it's going to go forward. It'll count the line, and then it'll go to the second line, and it'll go back 3 times and adjust. I just wanted to explain here that our robot will go forward, and then after it'll delay, then it counts only if it's off tape. So our project works for only regular thickness tape. If we were to thicken the tape, this wouldn't work. What we would have to do is take into account another variable and write the code for that situation, and we could get it to work, but as it sits right now, our code only works for regular thickness tape. So that explains our project 2.